So a power series is basically when we have a regular series, but we attach a variable x to each term. So you can see the general form of a power series is a sub n, which is the coefficient of each term. This is just like the regular part of a series. And then it's attached to this x minus c to the nth power, where c is a constant, which is where the power series is centered around. Remember when you did Taylor and Fgilan polynomials, you made a polynomial centered around some number, like centered at 2. So then this c would be 2. So power series were going to be used to approximate functions, just like Taylor and Fgilan polynomials. And one of the reasons power series are useful is because if you look at the expanded form, you'll notice that it's just a very long polynomial. We have a constant and then a term with x to the first power, the second power, and so on. And as you know, it's very easy to differentiate or integrate a polynomial. And so if we have a very complicated function that we can't integrate or differentiate, if we can represent it as a power series, now it's going to be easier to do that. So obviously, if we're representing a function with a power series, we're going to want this series to actually converge to a value. And so if we plug in a value of x, then this series could converge or diverge. So we want to know what values of x can we plug in so that the series will converge. And all the values of x that make a power series converge are called the interval of convergence. And the radius of convergence is basically half of that interval around the center. Okay, so the easiest functions to find a power series representation for are those that are just the sum of a geometric series. Remember that the sum of a convergent geometric series is a over 1 minus where a is the initial term and is the ratio, which is less than 1 in a convergent series. So if we see any function in this form, a over 1 minus then we can easily write a power series because we know it's just going to be a geometric series. So for example, we have this function 1 over 1 plus x squared. And we want to find a power series centered at 0. So if we compare it to a over 1 minus we see that a is going to be 1 and the ratio must be negative x squared. So then we can write a geometric series, which is just the initial value 1 times the ratio negative x squared to the n power. And this is the expanded form. So we can test the interval of convergence because the ratio negative x squared must be less than 1, the absolute value of this ratio. So then x is going to be between negative 1 and 1. And so this is the interval of convergence, and the radius of convergence is going to be 1. Because we're centered at 0, and we go out 1 to either side of 0. So for this function, 1 over 4 plus x, we need to divide by 4, divide the top and bottom both by 4 in order to get it in the form a over 1 minus So when we divide by 4, we get this, and then we can see that a is 1/4 and the ratio is negative 1/4 x. So then we can write a geometric power series, 1/4 times the ratio to the n power. And then we know that the absolute value of the ratio must be less than 1. So we can solve for x in this inequality to get the interval of convergence. And it's from negative 4 to 4. So since we're centered at 0 and we go out 4 to both sides, the radius of convergence is 4. Now the last one, we're going to make a power series not centered at 0, but centered at 2. So to do that, first we switch these terms just to get it in the right format. And then if it's centered at 2, instead of x, we need to have x minus 2. Remember, we have the x minus c in the power series, where c is the center. So we replace the x with x minus 2, but when we do that, we need to add this 4. Because if we distribute this 2 here, we get plus 2x minus 4. So we can't actually change anything, so we need to add this 4 to cancel out with the minus 4 that we made by replacing the x with the x minus 2. So that way, when we expand this, it'll be a negative 1 plus 2x minus 4 plus 4. So the 4's will cancel out, and we'll just have this. We didn't actually change anything. So we move the 4 with this guy to get 3, and then we need this to be a 1 to fit the a over 1 minus a. So we divide the top and bottom by 3. So we get that a is equal to 5, and the ratio is negative 2/3 times x minus 2. So then we write the power series, a times the ratio to the nth power. And we know that the ratio, the absolute value of the ratio, is less than 1. So if we solve for x in this inequality, we get the interval of convergence is 1/2 to 7/2. And remember, we're centered at 2, so we have to go from 2, we have to go 3/2 out on either side. So the radius of convergence is 3/2. And one way you can check your work when you're making these power series is that the first term in your power series should equal the value of the function at the center. So here, if we plug in 2 to the function, we get 15 over 3, which is 5. And so 5 is the first term in our power series, so it's probably right. Here, at x equals 0, the function is equal to 1/4, which is the first term in our power series. So just make sure that the first term matches up with the value of the function, because remember, the power series is basically just a representation of this function. So the value at the center should be exactly the same.